Paper 2, question 13, part D. There's all our answers from 13 parts A, B, and C. And so for part D, this line which we've just constructed, we have to find out where it meets the curve again. So I'm just going to extend it out and find the intersection point at this point there. So I'll do menu, analyze graph, intersection point of lower bound and upper bound. And it doesn't seem to like that because this line is not a function. So let's see if I can plot a point on it. So menu, geometry, points and lines. I'm just going to go for point, and it will snap to an intersection point there. Let's press escape to get out of point mode, and let's get the coordinates of that point. So I'll press control menu, and I get 0.361. So I'm wanting to evaluate an integral from -4/3 to this value of 0.361. So to save me doing a whole lot of typing in a minute, what I'm going to do is I'm going to go over that text and press control menu to store, and I'm going to store that in B for my upper bound, and I'm going to go to my -4/3. I'm going to store that in A. So I'm going to do an integral between A and B. Look at the area I'm interested in, which is made by this line. The equation of that line, you may remember, is 0.14x plus 1.19, and I'm going to have to subtract off f1 of x. So let's go to a calculator page and let's type in this definite integral. So I'll go to templates. I'm going to pull up the definite integral template. I'm going to go from the value of a to b. Now the equation I'm going to type in there is going to be the equation of the normal, which was 0.14x plus 1.19. 1.19, let's just double check I've remembered that correctly. Yes, it is. And I'm going to subtract from that f1 of x, the original function, and tab out to be x, and the value of this area of 0.818 may have rounding errors in it because this original linear equation was only done to 2 decimal places. So we're probably confident that this answer here is good to 2 decimal places, but not any more than that. In order to get a more accurate answer, we would have had to get used a more accurate equation for the line of the normal. But at least that shows you're on the right tracks if you did it by any other approach, and you got a similar answer. We're done.